Hello everyone, welcome back to the second part of physical change and chemical change. So in the previous episode, I think you already have gone through those physical changes which I explained to you, and a few chemical changes also I have explained there. So today the rest of the lesson I'll be completing with all the chemical changes experiments, and we will compare also between the physical change and chemical change. So don't skip in between, please go through the full video because it is going to be a very interesting one, and stay tuned throughout the lesson. So let's get started. So till experiment 5.6 we have done in the previous lesson or episode. If you have not gone through that, I'll be sharing the link in the I link above as well as the description box below. So please do go through it. Now, experiment 5.7. Now dissolve about a teaspoonful of copper sulfate or blue vitriol in half a cup of water in a glass, tumbler or a beaker. So it's better you take a cup or a glass and you just a teaspoonful of copper sulfate or blue vitriol you add in it. Now then to it you add a few drops of sulfuric acid. Okay, so to that solution of copper sulfate you are adding few 2 to 3 drops of dilute sulfuric acid. So it's very important that you are taking dilute sulfuric acid and adding it to that glass or cup. Now you should get a blue colored solution. You are getting a blue colored solution. Now save a small sample of solution in a test tube. So from this solution you are taking out a part and saving it in the test tube or a small glass bottle. Now you are dropping a nail or a used shaving blade into this solution which you have prepared with water, copper sulfate or blue vitriol, or you have where you have added a few drops of sulfuric acid, right? In that you are dropping a nail or a used shaving blade. So wait for half an hour or so. Now observe the color of the solution. So the color you have prepared was blue. Compare it with the color of the sample solution saved separately. You have kept in a beaker, right? So what has happened here? You see the copper sulfate solution was blue in color. After iron blade was dropped in it, it has become green in color. Okay, the change in color has appeared. The copper sulfate has reacted to this iron and it has changed to iron sulfate. Okay, did you see any color change in the solution? Yes, you have seen a color change in the solution. Take out the nail or the blade. Has it changed in any way? Yes, the color of the nail has also changed. So on iron, copper has been deposited. Now these changes are due to the reaction and between copper sulfate and iron. So what is the change which has happened? The change of color of the solution from blue to green is due to the formation of iron sulfate. So from copper sulfate it has converted to iron sulfate. A new substance is formed and the brown deposit on the iron nail is copper. So on the iron nail we have seen a deposit of copper is there. Another new substance is formed. So we can write the reaction as this. The copper sulfate solution plus iron is iron sulfate, and plus copper has been formed which has been deposited on the iron blade or iron nail, whatever you have taken. So this also should be demonstrated by the teacher because you can't handle, you are a 7th standard kid, you can't handle with dilute sulfuric acid solution or you can't handle with these chemicals on your own. So you should tell your teacher to take you to lab and you should do these experiments in the lab itself, right? Now there is another activity, activity 5.8. So here comes our next activity, activity 5.8. So we are taking a spoonful of vinegar in a test tube. So and then we are adding a pinch of baking soda to it and we are hearing a hissing sound and we see the bubbles of gas coming out. Passing through this freshly prepared lime water, if we are passing this gas through freshly prepared lime water, what we will see? The lime water will turn milky. So let us see this experiment down in this, how it is done. Now if this is the test tube, we are taking vinegar and baking soda, pinch of baking soda in it, effervescence will occur and bubbles will start coming out, and this is passed, this gas is passed through freshly prepared lime water, and it turns the lime water milky, which proves that it is containing carbon dioxide. Okay, so what is happening here? Then what is prepared after that? We can say what reaction is happening here. The change in the test tube is as follows: vinegar or acetic acid plus baking soda. In other words, we can also call it that sodium hydrogen carbonate. Okay, sodium bicarbonate or sodium hydrogen carbonate. So baking soda and vinegar or acetic acid gives the products carbon dioxide and other substances. Carbon dioxide in turn, when it reacts with lime water, it forms calcium carbonate, and we will see it is forming calcium carbonate and water. Okay, so lime water, what is lime water? Lime water is generally calcium hydroxide. So carbon dioxide on reaction with calcium hydroxide is giving rise to calcium carbonate and water. So you just need to remember or memorize these equations a bit. So no need of any balanced equation, just you need to know that which all substances are reacting and what new substances are formed. So carbon dioxide is reacting with lime water. Lime water, in other words, it's called calcium hydroxide, and which in turn is giving calcium carbonate and water. Okay, so when carbon dioxide is passed through lime water, calcium carbonate is formed, which is turning the lime water milky. So the turning of lime water milky is a standard test of carbon dioxide. So you will also use it in the chapter 6, next chapter, where to show that we breathe out air rich in carbon dioxide, right? So activities 5.6 to 5.8, you saw that each change one or more substances were formed, and in activity 5.6 the ash was new substance from the burning of magnesium ribbon. Okay, so I think you remember that when we burnt in the previous episode, we have done that in the previous part of the lesson. Please go through that video. When we burnt a piece of magnesium ribbon, the ashes we formed, they are a new substance. Okay, so they are magnesium oxide. So they are a new substance and they are not the magnesium ribbon itself. So in activity 5.7, the copper sulfate is reacting with iron and producing iron sulfate and copper. So here also two new substances are formed. So copper was deposited on the shaving blade of iron. Now in this activity, vinegar and baking soda together produced carbon dioxide, and which turned lime water milky. So can you name the new substance formed in this reaction? Yes. So the new substance formed is calcium carbonate. We have just now told that. Now a change in which one or more new substances are formed is called a chemical change, and this reaction is called a chemical reaction. Is it clear? So in previous class we have spoken about physical change, and now we are speaking about the chemical change. Now chemical changes are very important in our life. All new substances are formed through this chemical changes only. Physical changes are only changes in property, color, state, shape, size and all, but no new substances are formed in physical changes, right? Like the digestion of food in our body, ripening of fruits, fermentation of grapes happens only in chemical changes only. Now a medicine is the end product of a chain of chemical reactions. So useful new materials such as plastics, detergents are produced through chemical reactions indeed. So we have seen that one or more new substances are produced in chemical change, and in addition to the substances formed, they are accompanied by many new substances are formed. So what are they? Now heat, light or any other radiation may be given off or absorbed during this chemical reaction. Sound may be produced, a change in smell may take place, or a new smell may be given off. A color change may take place, a gas may be formed. So many changes may happen during this chemical reaction. So color change, smell, you can odor of a particular substance, new substance formed, you can smell. Sound may be produced. So let us give some examples like magnesium ribbon is a chemical change. Burning of coal, wood, leaves a chemical change. So all these substances burning, they produce heat, right? So they are all chemical changes. Now, here comes explosion of fireworks. So when in Diwali you are burning firecrackers, you know that it is producing a large amount of smoke, heat, and also heat, light, sound, and unpleasant gases that pollute the atmosphere. So that is why you are not as advised to play with the fireworks. So this is a chemical reaction. When food gets spoiled, it produces a foul smell. So shall we call this a chemical change? So all these are chemical changes because a new compound is formed after decomposition and you can't revert it into the original form. So you may have noticed that a slice of apple acquires a brown color if it is not consumed immediately. So if your mother is giving you slices of apple in your lunch break or in a tiffin box, you will see that it has become brownish in color. So because it has iron in the apple present, reacts with the oxygen of the atmosphere and it becomes iron oxide. So that brownish color is due to that a new chemical substances form, and there is also obviously a chemical reaction. So repeat the same activity with the slice of potato or brinjal. In that cases also formation of new substances happen. So we can ask you a question, that is neutralization a chemical change? Now in the previous lesson when we spoke about acid, base and salt, we have spoken about the neutralization process. So neutralization is obviously a chemical change because it is an irreversible change which cannot be reversed, right? So we can take a look of here. We have learned in chapter 1 that plants provide their food by a process of photosynthesis. Can we call photosynthesis a chemical change? Paheli said that even digestion is also a chemical change. So anything new is produced from a certain reaction is a chemical change. Now we will just stress on this rusting of iron. Let us get back to that. Now, rusting of iron, let us get back to rusting. This is one of the changes that affects the iron particles and slowly destroys them, since iron is used in making bridges, ships, cars, truck bodies, and many other articles. The monetary loss due to rusting is huge. So what happens when rusting is happening? So iron, when it is exposed to oxygen from the air and water vapor from the atmosphere is there, rust or iron oxide is formed. So Fe2O3 is iron oxide. So for rusting, the presence of both oxygen and water or water vapor is very much essential. So whenever an iron is left open for some time in open air, so that is forming iron oxide or rust. So in fact, if the content of moisture in air is high, which means if it is more humid, rusting is faster. How to prevent rusting? Prevent iron particles from coming in contact with oxygen or both, or we can say or water or both. So one simple way is to apply a coat of paint or grease on it. So in fact, these coats should be applied regularly to prevent rusting. Another way is to deposit a layer of metal like chromium or zinc on iron. So if you are layering a deposit of chromium or zinc or iron, then what will happen? This process of depositing a layer of chromium or zinc on iron, this is called galvanization. So what is this process? If you are coating the iron with a layer of zinc or chromium, this process, though it is called galvanization, the iron pipes we are using at home to carry water are galvanized, and this coating will prevent the iron from rusting. Is it clear? So when one's coating of chromium or zinc is done on the iron ships, or you can iron pipes and all, they are not getting rusted. So you know the ships are made up of iron, and the part of them which remains underwater, on the part above water also, water drops keep clinging to the ship's outer surface. So they don't get rusted easily, right? They are being galvanized or given a coating of this chromium and zinc. So moreover, the water of the sea contains many salts. The salt water make the process of rust formation faster. So the ships suffer a lot of damage from this rusting in spite of being painted also.
So much so that the fraction of ship's iron has to be replaced every year, right? So stainless steel is made by mixing iron with carbon and metals like chromium, nickel, manganese, etc. So it does not rust. If it is a proper stainless steel, it is made of mixing stainless steel with iron. We can say that it is made by mixing iron with carbon and metals like chromium, zinc and manganese, and it does not rust easily, right? So this is how we can prevent metals from getting iron from getting rusted. Now we will come to another technique, that is crystallization. So let us deal with this one. Now we are coming to this crystallization. Now in class 6, I think you have learnt about the salt that can be obtained by evaporation of seawater. So when you are taking a seawater in a container and you are heating it till it evaporates, you can find some salt left over in the container. Now the salt obtained in this manner is not pure and the shape of the crystals cannot be seen clearly. However, large crystals of pure substances can be formed from their solutions, and this process of forming substances by this process is called crystallization, and it is an example of physical change. It is not a chemical change, right? Now this activity 5.9 is the last activity. So we have performed so many activities to see or to learn physical change and chemical change. So this is the last one to be performed in presence of teacher, obviously. So use only dilute sulfuric acid and be very much careful while boiling water. So what you are doing, you are taking a cup full of water in a beaker, adding a few drops of sulfuric acid. You are heating the water. When it starts boiling, you are adding copper sulfate powder very slowly while stirring it continuously, right? So you have taken a cup full of water with a few drops of sulfuric acid, and then you are adding copper sulfate powder when the water starts boiling, and you are constantly stirring the solution, right? Now continue this adding copper sulfate solution till no more powder is getting dissolved in this water and acid solution rather. Filter the solution, allow it to cool, and do not disturb the solution when it is cooling. Look at this solution after some time. Can you see the crystals of copper sulfate? If not, wait for some more time. You can see the crystals of copper sulfate down in this solution, right? So these changes that you observe around you are physical as well as many chemical changes are there. So what do you have learned in this lesson? We have learned about chemical change, chemical reaction, crystallization, galvanization, physical change and rusting through 9 experiments. So you just need to do these exercises or whatever exercises you are having in your textbook. Do those exercises. If you want to do these exercises also, go through this, pause the video, go through the first page once and then go through other part of the exercises again, so that you can do this, fill in the blanks of this. You can do this, what type of change is it, explain. So these are very easy, and I have taught you each and everything in this physical and chemical change. So try to answer all these questions, and if you are having any queries, any doubts, just pause the video, answer these questions. Any queries, any doubts, just ask me in the comment box so that I can get back to you with the answers and in the next video itself, and I'll clear all your doubts. So for that, for your clearing doubts, for waiting for the next video, you need to stay tuned, stay updated, subscribe to my channel, and please don't skip the lessons or videos in between, because throughout the lesson I'll be teaching you many new concepts. So stay tuned, stay updated, and keep on watching my videos and keep on enjoying my teaching. Thank you. Thanks a lot.